My name is Anna Tenbencil, and we are on question number 39 in LeetCode problem set. And again, I apologize you're not seeing my face and watching me work through this at my own time. I'm having issues with my Loom. So I want to go ahead and show you guys my submission for this. I submitted about 15 minutes ago, so it took me about 30 minutes from the previous problem that I just did, which was 38, which also took me about 30-ish or so minutes. But I do want to show you the results for this also because while it did really great with runtime, it did not do good with memory. So there is definitely room for improvement here. I will let you guys read this question on your own time, but I'm going to go ahead and explain my logic and the process in this code. But number 39 is combination sum, and this is the part that comes preloaded on the page, but we start here. So I decided that for this code, I wanted to figure out how to do some backtracking with this. So I start with defining this nested function here, backtrack, which takes 3 parameters. It takes start, target, and path. And start is the starting index and candidates. Target is the remaining target value, and then path is the current combination being formed. So when target becomes 0, that means the current combination path sums up to the target, so it's added into the results list. So in the backtrack function, we iterate through the candidates starting from the start index, and if the current candidate is greater than the remaining target, like you can see here, it continues to the next candidate. Otherwise, it recursively calls the backtrack with updated parameters. So the new start index, which is the same candidate that can be used multiple times, the reduced target, and the path list with the current candidates added. And then after defining the backtrack function, it initializes the result to store the combination. It also sorts the candidates in ascending order to help with like the early termination in the backtracking process, and then also initiates the backtracking process by calling backtrack with the initial values start at index 0, and then given the target and an empty path. And then the result just is a list that accumulates all of the valid combinations and the list containing the unique combinations of those candidates that sum up to the target values. So that was how I chose to tackle this problem. And again, it did really well with runtime, but it did not do well with memory. So I will be leaving this solution in the GitHub repo that I have in the video description down below. You guys are more than welcome to fork, clone, make it better, make it worse, learn something new, have some fun, and I will see you guys in the next video where I will actually be able to code this in real time. So thank you guys so much for watching, and I will see you in the next video.